I've got two very important definitions up here on the board. The definition of a relative max for a function and a relative min for a function. So the first says that f of a, now notice that's the y value I get when I plug a into a function. That's a relative max of f if there's some open interval containing a such that f of a is bigger than or equal to f of x for all x in that interval. So we're basically talking about a high point, and you can see right here, when x is a, my y value is f of a, we're at a high point on the graph here. Now we call it a relative max because we're not insisting that it's the highest point ever. I can see over here, the function gets higher than it is here. But this notion of there being some open interval containing a, if I just look a little to the left and a little to the right of a, I don't see any point that's higher. So we call that a relative max. Okay. Now, f of a would be the value of the max. A would be the location of the max. Sometimes I might ask you to find the location and the value of a max or a min. That's two separate questions with two separate answers. Neither of them has as their answer the point a comma f of a. That's combining the answers to both questions. The x value is where the max or min occurs, and the y value is what the max or min is. The reason that's very important is in applications. There are times when we're going to care about what's the x value and other times when we're going to care about what's the y value. Let's say you're going into business and you want to try to maximize profit. Okay. Well, if you determine that the maximum profit you could get is $5 million, that sounds pretty good. I might like to have $5 million. So you might say, well, what do I have to do to get that $5 million? And then maybe your profit was a function of x, where x was the number of products you produced. And you determined that in order to get that profit of $5 million, you need to manufacture 20 billion products. Well, you have one factory. You don't have the capacity to manufacture that many. There, the location, the x value that would give you that maximum, tells you this isn't possible under current circumstances. Okay. On the other hand, let's suppose that you determined that with a particular business venture, you could maximize profit and your maximum profit would be 3 cents. I'm going into another business because that's not worth it. So there are times when I care about what is the value that I could achieve, and there are other times I care about what do I need to do to achieve that. So there are different questions that we can answer by talking about the location versus the value of a max or a min. Okay. All right. Now, let's see. Location of a min is very similar. F of b, that's the y value, is a relative min if there's some open interval containing b such that the y value at b is less than or equal to the y values at other x values for all x in that interval. So you can see here at b, I've got a value, and that's my min. If I look just a little to the left and a little to the right, I never see a point that's lower. Okay. Now, if I look over here, it does look like that point is a little bit lower than this, although I don't really care. This is still a min. I do want to point out this right here, that value, if I call that c f of c, f of c is not a relative min because it does not meet this definition. The definition requires that there be some open interval containing the x value that I'm saying is the location of my min that's in the domain of my function. Now here, if I'm at c, at this x value, and I look a little to the left, there's nothing to compare it to. I can look a little to the right, and certainly this point is lower than any point that's a little bit to the right of it, but there's nothing to compare it to if it's a little bit to the left. So part of the definition of a relative max or min is that the function has to be defined not just at that point, but a little to the left and a little to the right. So if you have a function whose domain includes a finite endpoint like this, No matter how high up or low down that point is, it does not count as a relative max or min. So that's one important technicality that comes from this definition. Now there's another thing called an absolute max or min, and you'll be studying both of those in calculus. If this is actually the lowest point, it does look like that's lower, absolute maxes and mins are allowed to occur at endpoints. So I could say f of c is the absolute min for this function, but a relative min has to occur at some point that isn't an endpoint for the function. It's an important technicality. Why that's important? Not at all obvious. That's just the definition, so that's just a teacher being picky. Becomes important in calculus because of the technique you're going to use when you get to calculus for finding relative maxes and mins. That actually does become an important technicality that makes a certain technique work for finding relative maxes and mins. All right, one other technicality that I want to just point out is that these inequalities are inclusive inequalities. So, if I have something like so, where there's a plateau, let's just introduce my axes, okay, this definitely counts as being a relative max, whatever the y value is at this point. I like to do a lot of hiking, and very often when I'm hiking, I like to climb to the top of a mountain. And the top of a mountain is generally a relative max. When I get to the top, I don't say, well, I didn't climb Everest, so it doesn't count. I say, I have climbed to the top of a mountain. It is time to eat my celebratory Snickers bar. And I stop and I eat my celebratory Snickers bar. Now, if I climb to the top of a mountain and it's flat on the top, I don't say, oh, that doesn't count. I won't eat my Snickers bar. No, I just did that climb. I'm going to eat my celebratory Snickers bar. So plateaus count. Now, very interesting technicality. Let's just suppose this is let's not use A and B, let's use C and D. Okay, so here I've got the point C, f of C. Here I've got the point D, f of D. And of course, f of C and f of D are exactly the same. Okay. Well, every single point between here and here, it involves a relative max. The y value is exactly the same. Let's just say the y value was 2. Okay. So I would say 2 is a relative max. The location of that relative max would be every x value in between C and D, including C and D, because if I'm at C and I look a little to the left, I don't see anything higher. If I look a little to the right, I don't see anything higher. So it's not that I have to be at the highest point, it's that if I look nearby, I don't see anything higher. Now, very interesting technicality. If I'm right here, let's just call that point, I'm going to call it capital E, since E is actually a number. I don't want to, lowercase e is actually a number. I don't want to confuse us with that. All right, here, okay, so this would be the point E2. 2 is a relative max. 2 is also a relative min. Because if I look just a little bit to the left and a little bit to the right of E, as long as I don't go so far to the left and right that I'm looking over here, if I look just a little to the left and the right, I don't see anything lower. I don't see anything higher. So it's a relative min as well as a relative max, because there's nothing lower, there's nothing higher. Okay. Sorry, it's a relative min because I don't see anything lower. I think I misspoke a minute ago. But if I don't see anything lower, then that's the lowest point in this interval. And so 2 counts as both a relative max and a relative min. The location of the relative max would be everything from C to D, including those endpoints. At C, C is not the location of a relative min, because if I look just a little bit to the left, I do see things that are lower. Same thing for E. But plateaus are very interesting, because with the possible exception of the endpoints, points on a plateau count as both the highest point around and the lowest point around. So that y value is both a relative max and a relative min. All right, in the next video, we'll try putting all these definitions together and just looking at some graphs to try to figure out where things are increasing, decreasing, constant, and find the location and value of relative maxes and mins.